Complex fractions are just a fraction in a fraction. So if I had 2/3 over 1/5, that would be an example of a complex fraction. This would be equivalent to the statement 2/3 divided by 1/5, which in turn would become 2/3 times 5 over 1, the multiplication problem. You could multiply the numerators, 2 times 5, get 10. Multiply the denominators, 3 times 1 is 3. A better way might be to approach this by finding the LCD of each one of these fractions. So in this example, the LCD would be 15. Once we find the LCD, we want to multiply the numerator and the denominator by this LCD. Once we multiply the numerator and denominator by the LCD, we could cancel out those LCDs. 3 goes into 15 5 times, 5 goes into 15 3 times, and then we could perform the multiplication operation. 2 times 5 is 10, and 1 times 3 is 3. In this third example, we could do this one of the two ways from above. So we could actually do the addition of the numerator, the subtraction of the denominator. Then once we get the result, we could change it into a division problem, which would then change into a multiplication problem, and then we could evaluate it from there. Or we could find the LCD, cancel out the denominators, which is what this should say, cancel out the denominators, and then perform the indicated operation. Let's try it that way. So the LCD in this case, I have 2, 3, 4, and 6. It looks like my LCD is going to be equal to 12, a value that all of those could go into. So I want to multiply each one by 12. And then I want to cancel out these denominators. So 2 goes into 12 6 times. 6 times 1 is 6. 3 goes into 12 4 times. 5 times 4 is 20. 4 goes into 12 3 times. 3 times 7 is 21. 6 goes into 12 2 times. 11 times 2 is 22. And now we could perform the operation of the numerator and denominator. 6 plus 20 is 26. And 21 minus 22 is a negative 1. And we could simplify that to negative 26. In this next example, we have 1/6 minus 6 over x squared over 1/6 plus 2 over x plus 6 over x squared. So it looks more complicated, but it's really not. We still just want to find the LCD. So in this case, my LCD of 6, x squared, 6x, and x squared, my LCD is 6x squared. We want a value that's going to be able to cancel out 6, x squared, 6, x to the first, something that all these denominators could go into. So we're going to write 6x squared, 6x squared, 6x squared, 6x squared, 6x squared. We're multiplying all of the numerators, I said it correctly, numerators by 6x squared. When we multiply the numerator by 6x squared, we're able to cancel out the denominator. right? This is a pi x squared. That's going to cancel out, leaving me just with 6. Here my 6's will just cancel out, leaving me with x squared. So my new numerator is x squared minus 6. Here my 6's cancel out, leaving me with x squared. Here one of my x's cancel out. I have x squared and x to the first. So here up top I have 2 x's, here I have 1. So I could cancel 1 out with 1. This gives me 12x plus 36, right? X squared and x squared cancels out. So now I no longer have a complex fraction. In order to simplify this, all I have to do is factor and cancel. The numerator is the difference of 2 perfect squares. Oops, I made a mistake. That should have been 36. 6 times 6 is 36. So I'm going to have x times x and 6 times 6. The denominator in this case is a perfect square trinomial. X times x gives me x squared. 6 times 6 gives me 36. And the inners and the outers give me 12. Once I factor it completely, I could cancel out my like factors, x plus 6, x plus 6. So my final answer in this case is x minus 6 over x plus 6. So just to review quickly, we found the LCD, we multiplied each value by the LCD, we canceled out the denominators, and then we simplified. In this case, simplifying was factoring and canceling. This next example is very simple. It says 8 plus 1 over x over 4 minus 1 over x. So in this case, my LCD is obviously x, right? Because this is really like 8 over 1 and 4 over 1. So you could say my LCD is 1x. Oh, look. My LCD is 1x. So I want to multiply everything by that 1x, or just x. 1 times x is just x. So here I'm multiplying 8 times x. That gives me 8x plus, my x's cancel out here. Here I have x times 4, which is 4x, and my x's cancel out here. This can't be simplified. The only way to simplify this rational expression would be by factoring and canceling. And there's no greatest common factor. It's not the difference of squares. This can't be factored, so this can't be simplified in any way. My final answer. In this last example, this example looks a little bit more difficult. We have binomials in the denominator. And in order to find an LCD in this case, we want to see all the factors of the binomial. So we're going to have to factor this denominator, which is the difference of 2 perfect squares, right? So now I could look at this. X squared minus 4 is now really x plus 2, x minus 2. So now I'm looking to identify my LCD in this case. My LCD has to be a value that's going to be able to cancel out all these denominators, right? Something that all these denominators could go into. So my LCD in this case looks like it's going to be x plus 2, x minus 2. So I want to multiply every term by x plus 2, x minus 2, which is the equivalent of x squared minus 4. So I'm multiplying each of the terms by the LCD. I could cancel out x minus 2 with x minus 2. So that leaves me with x times x plus 2 plus x plus 2 times x plus 2 times 1 will just be x squared minus 4, right? If I multiply those together, we agree it's x squared minus 4. On the bottom here, x plus 2, x minus 2 cancels out with x plus 2, x minus 2. And again, I have 1 times x squared minus 4. You could write it as x plus 2, x minus 2 up here, but eventually we're going to have to get rid of the parentheses by distributing. So if you don't do it back here, you'll have to do it here. It doesn't make a difference. So it looks like I'm going to have x squared plus 2x plus x squared minus 4 all over 3 plus x squared minus 4. I remove my parentheses. Now I can combine my like terms. What are my like terms here? X squared and x squared. So it looks like I'm going to have 2x squared plus 2x minus 4 all over. My like terms here are 3 and negative 4. So it looks like I'm going to have x squared minus 1. This looks like it could be simplified. I'm going to factor and cancel from this point. When I factor, I have to look for a, first step is always to look for a GCF. And in this case, I do have a GCF up top here. It looks like I could take out a 2, and I'd be left with x squared plus x minus 2. On the bottom, there is no GCF. This would just be the difference of two perfect squares. This top could be factored a little bit further, I think. So I'm going to have 2x and x will give me my x squared. 1 times 2 gives me 2, and my inners and outers have to give me a positive 1. And on the bottom, x plus 1, x minus 1. Once it's factored completely, I could cancel out my like factors. And it looks like my final answer in this case is 2x plus 2 over x plus 1. So that last example was kind of complicated. The reality of it is, as you go on from college algebra to pre-calc, a lot of the complex fractions will be relatively simple. So it's really a shortcut to doing these problems. Here's 3 examples that you might run into. In this example, we have a complex fraction. My LCD is 2, so I could multiply the top and the bottom by 2. And I could see that this will cancel out my denominators, and that will give me 1 over radical 3. Which I wouldn't leave my answer as 1 over radical 3. I would have to rationalize that denominator. And my final answer would look like that. In this example, this next example, the same thing. My LCD is 2. In fact, when my denominators are the same, I could actually just ignore them. Right? If I just ignored those two denominators because they're the same, I'd have 1 over radical 3. A lot of times in pre-calculus or calculus, the course is difficult because your professor goes from here to here without showing the algebra. They're assuming you know the algebra. So right away, I could see in my head, if I ignore these denominators of 2, if I get rid of that 2 and that 2, I'm left with radical 2 over radical 2. My final answer here is going to be 1. So your professor might see this and write 1. Algebraically, this is what's going on. Similarly, for this one, I could see right away my final answer is radical 3. Because my denominators are the same, so it's really rad 3 over 1. So that's it for complex fractions. We'll move on to the next topic.